All right, let's move it. Today's topic is going to be on index numbers. Okay, everybody there? Hello.
Yes, Professor.
All right.
Hello.
Okay. Glad to hear from you all. So yes, we're going to talk about index numbers. So we are moving away from statistical hypothesis testing, including regression analysis. We are going to get into a new topic that is very, very important in statistics, in statistical analysis, and we're going to get into a topic that features very strongly in policy making, in data analysis, that is called index numbers. So I'm just going to share screen, and I'm going to pull up some files so that you will see exactly what we mean by index numbers. So we share screen. All right. So you see my screen?
Yes, Professor.
All right. Okay, so we're going to talk about index numbers. Now, index number is really a measure of relative values. That is what it is. It's a measure of relative values. So when we say relative values, I'm going to provide some examples here of what we mean by relative values or how we use index numbers. Okay. All right. So it's a measure of relative values. It's used to compare two numbers as to their relative magnitudes. And essentially, you're dealing with a ratio of one number to another. But then of what importance are those ratios? So index number is not anything particularly heroic. It can be somewhat complex to compute depending on how much you really want to provide for yourself what you might call a valid measure. Okay, a valid measure is a measure that really represents exactly the information that you want to obtain out of it. So it's also used to measure relative change, say in prices, in quantities, in values, or some other item of interest, from one period to another. You can use it to compare one say unit to another. For example, you can use it to compare China to United States. You can use it to compare different countries and use an index number. And we're going to measure, we're going to illustrate what these comparisons can be. You can measure relative populations using index, an index of populations, an index of salaries, an index of prices. You can measure an index of quantities. Okay, and examples we have, say, import quantity index. Okay, let us say that United States imported 100 automobiles last year, and this year you imported 120 automobiles. So you have an index of 1.2, 120 divided by 100. You have consumer price index, which enables us to measure inflation, which enables us also to measure purchasing power. Okay, and so we have import price index. Okay, other indices will be like producer's price index. So let's move on and see how we illustrate the indices. Okay. All right. Now, there are different types of indices, from the simple to the complex, even more complex than what you have here. When you want to compare lots of items together, okay? Now, there's something called a very simple index. A very simple index is a ratio over time. And then there's what we call simple aggregate index. And then there is also an unweighted aggregate index. Now, aggregate means that several, let us say you are looking at a basket of goods that you consume, as an individual. You have clothing, you have medication, you have food, you have transportation. And so if you try to get an index, say of prices or of quantities, you measure, say, an unweighted aggregate index of the prices of all these goods combined. Okay, you can let us say that United States imports apples, oranges, they import meat, they import grain, say they import wheat, they import rice, and they import barley. And so when you think about aggregate index, you're thinking about creating an index of all these goods, okay? Either in terms of their prices, or in terms of their quantities, or in terms of their values, and you create an aggregate index, okay? Now, there are different ways of measuring aggregate indices, okay? There is a Las Payas index, there is a Pash index. Of course, then there's a value index, which is actually a measure of, combined values, okay? And so there's a Fisher's index. We're not going to talk about Fisher's index today. We may or may not, if we, just don't want to complicate things. Like I said, indexes can become very, very complicated. Now, this is an example of a simple index, okay? And I'm going to illustrate this quite easily, okay? For example, you are looking at, say, the stadium capacity of football games or stadium capacities. And so here you have Arizona has a capacity of 48,000 seats, Atlanta 49,000, Baltimore 45,000, and so forth and so on. The salaries that are paid to players in Arizona in the millions, the total salaries. Again, you see that different cities, different units have different total salaries. You see the number of wins, okay? Arizona as a team, Atlanta as a team, Baltimore as a team, Red Sox as a team, they have different wins. So now what you try to do, if you want to compile what is called a simple index, you want to compare all the teams to Arizona. So Arizona becomes what you call the base team. So I'm going to call this the base team, okay? Now, so when we say Arizona is the base, then we are comparing Arizona to everybody else. That is what we are doing. So in doing that, what we simply do is to take each of these variables, the wins, the salaries, the capacity, and then we compare them to Arizona, the base, by dividing these values to Arizona. So, for example, we divide Atlanta to Arizona, so 83.3 divided by 74.3 will give you 1.02. So that simply means that Arizona is 2%, that Atlanta is 2% higher than Arizona. And then you take Baltimore and say the capacity of Baltimore is 45.9 divided by 48.6, and so Baltimore is 95% of Arizona. Okay, and the first time I was saying was actually to take 49 and divide it by 48. Not, I was looking at wins. Now, suppose you want to compare their wins, so you take the win of Atlanta divided by the win of Arizona, and you get 1.16. And so that means Atlanta has 16% more wins than Arizona. And Baltimore has 15% more wins than Arizona. So you divide everybody's figure with Arizona, and that gives you a simple index. Okay, and sometimes that's all you can get. You cannot, use any of these numbers to create a more complex index. And the reason you just want to do the index, you just want to see how each team is performing relative to the base. Okay, relative to the base. That's all you want to find out. And you're not going to be able to find more information out of this than this simple index. Okay, so we go from simple index. I think we identify different kinds of index. Didn't I talk about different kinds of index? Okay, all right. So we go from a simple index and we go into simple aggregate index. Now here we are talking about aggregate index, and as a simple aggregate index. Okay, all right. So that's a simple index, and this is very simple. We just illustrated that already. So let us. This is another example of simple index: steel production, where we are comparing other countries to China. And China, we have 197 over 197. So China is the base. China is the base unit, the base country. And so we take 197 over 197 and we have 100%. Okay. So now France is 144 over 197, which is 73% or 0.73, and so forth and so on. So we continue to illustrate another example of simple index. Okay, so we go from simple index, as I was about to say, to aggregate index. So we have simple, what we call unweighted aggregate index. And I'm going to illustrate that. And we're looking here at prices, relative prices, okay? So what we do is that we look at, say, the goods that people consume. Okay, we look at the goods that people consume. And so a simple aggregate index is that you're looking at different goods, okay, different items, all right? For example, bread. In 2003, bread cost $1.42 per pound, okay? And so in 2003, 1 dozen eggs cost $1.72. Now, remember here you're looking at pound, here you're looking at dozen units, and here you're looking at gallons. Okay, so we're looking at a simple aggregate index. That is the index of different goods, but in a simple way. And simple because we are looking here at pound, dozen, gallon, concentrate, and what have you. And so suppose you consumed this what do you call it? This basket of goods, this group of goods in 2003. How do you compare the cost of this basket of goods in 2003, and you are comparing them to the same basket of goods in 2013. The price here is $1.42. And so if you divide $1.42 over $1.04, you get 136 or 1.36. Okay. And you do the same thing. You divide $1.93 by $17.5, you get 16.4. So when you add all of that together, there are 6 goods here. Okay. And you divide all by 6 and you get 152. So, which to say that between 2003 and 2013, the price of this basket of goods increased by 52%, because now instead of 100, if you take 2003 to be 100, then you get an index of 152, which is 52% higher in 2003. Okay. Now, there's another way to look at a simple aggregate index. Okay. Now, you can do a simple aggregate index in another way. For example, here you look at the price of these goods, a very simplified, conceptualization. If you consumed these goods per unit in 2003, and you add their prices, and then you add the prices of the same goods, the units in 2013, so you sum the prices of the later period by the prices of the base period. Now, remember, you're looking at a base, okay? And the base period here is 2003. So 16 over 10 will give you 1.56. So if you use this method to calculate your index, you would say that prices increased by 56%, while the other method told you that prices increased by 52%. There are advantages, mathematical advantages, and also conceptual advantages and disadvantages in using either method. Okay, because you simply added all these prices here, which is to say, if you were to spend money on bread, 1 pound of bread and 1 dozen eggs and 1 gallon of milk and so forth and so on in 2003, the way you consume them per pound, you spend $10.6. While if you did the same in 2013, you will spend $16. That's what it says. So which of the two methods is better? I really don't know. I don't think that, it's a matter of choice. Let me just put it that way. Okay. This is an example of, a simple index, which we already did before. So you simply add these indexes. I think we illustrated that earlier. You add these indexes, like 1.35 or 1.04 is 1.296. And you do the same for X. 1.93 divided by 1.18 is 1.63. And so you add them up, you simply divide by the number of items, which means that the price of goods increased by 41% during that period. All right, so this is essentially an illustration of the point. This is, again, the other method of simple aggregate index that we illustrated earlier. Now, we get to more complex ways of doing index numbers. Okay, this is a little bit more complex. For example, we have what you call last payers index. We have the PASC index. We have a Fisher's ideal index. So let's begin with last payers index. Okay. So now the difference between the other indexes that we calculated is that we call this a weighted index. Okay, it's a weighted index. So we weight quantities by prices. Okay, we weighted quantities by prices. Now, the whole idea here is, and I'm going to use an illustration. We compare the total cost of the base year quantities using the target year prices. Okay, and I'm going to give you an interpretation. Okay. Suppose that you consume 1 apple in 2003. Let us say you consume 1 apple in 2003, 1 apple per week. Okay, and in 2013, you also consume 1 apple per week. That is the question. In 2003, you will buy that 1 apple for 50 cents. In 2013, you will buy that 1 apple for $1.50. So that means you would have spent 50 cents, 3 times more. The index will be 3. Okay, that means that in 2013, the cost of 1 apple costs you 3 times more, because if you divide $1.50 by 50 cents, you would get 3. So the index will be 3. Okay, we're going to illustrate that. This is what it says here. You sum the, if you consume the quantities at base period, the Q0 is the quantity at the base period, and the PT is the quantity for the new time period. And so if you consume the same quantity of goods in the future time period and compare it to what you would have paid for them in the base time period, that gives you a less payer index. Okay, again, it's a matter of choice what index you use. Here is an example. You have the 2003 prices. You have 2013 prices. Okay, so let us see what we do. We look at the prices. This is the price in 2000. This is the quantity in 2003, and that is the price in 2003. Okay. Now we have the price in 2013, but we are comparing them to the price, the quantity of 2013. So if you consume 2003 quantity, if you consume 1 pound of beef in 2003 and consume the same pound of beef in 2013, how much more would it cost you? Now, the difference here is that we are looking at different goods. And so we try to get an aggregate weighted index. So if you consume this same combination of goods in 2013, at the prices of 2013, how much more would it cost you? Or what would be the difference in the cost? Okay, and so here we have, in 2013, you would have paid 35% more. So for each dollar, you now pay $1.35. All right. So this is the computation for that. Now, there is what we call the past index. Okay, the past index. And so the past index, uses a different method. Okay. And so what does the past index mean? Okay. Now, it simply looks at that we are now weighting the price. We're now looking at the quantities for the future period. Okay. We are comparing them to the quantities for the base period. And if you were to look at it, you can see is the price of the future period, okay? The price of the future period and the quantities of the future period. And so the question is, if you had consumed the 2013 quantities in 2003, what would it have cost you in 2003, okay, compared to what it will cost you in 2013. And the answer is 38% more. Okay, and this is again an example that is different from what your book has. Now, the Fisher's ideal index is nothing more than you take the Las Vegas index and multiply it by the past index and get a square root. You have not done anything heroic. And so, that is how to compute the indexes. Now, I'm going to illustrate a simple index. Your homework assignment is going to consist of doing a simple index, okay? So I'm going to bring that up, okay? And so all I asked you for the homework assignment is to compare prices, the producer price indexes from 1950 to 1958, 1990 something. So I'm going to pull that up right away, so as to give you an idea. And so what you do is you simply compute the index and plot a graph. Let me see if I can pull it up. All right. Can you see my screen now?
Yes, Professor. Blackboard.
Yes.
All right. Okay. Thank you. So what I did in this assignment, okay, so you're seeing the blackboard, okay? So you download this file. You download this file here and you get your information. So what I'm gonna do is I'm going to stop share the blackboard and pull up an Excel file. Okay. I'm going to share the Excel. Are you seeing the Excel file?
Yes, Professor.
Yes.
Okay. Okay. So what I'm asking you in your homework assignment is to compare, say, the consumer price index to 1950 and use 1950 as a base, which is to say, when you look at prices in these other years, up to 2005, how do they compare to prices in 1950? So 1950 is your base year. So I'm going to call this CPI index. Okay, this is the CPI index. So the matter is very simple. So you go equals, since you're comparing to 1950 and we're comparing the CPI, so it's going to be J4 divided by $J $4. Okay, and I'm going to make it 100%. And you just drag it down. And so you can see how prices have changed between 1950. The consumer price index has changed between 1950 and 2005. Okay. And so you can plot a chart of that. You insert. All right. Move the chart. That's my style. Move this chart. All right. So this is the way the CPI has changed over the years. And then, of course, you label it. And you simply see there's been a decline here. Now, this is not real data. So don't go and tell anybody that I told you that the CPI declined over the years. That is not true. I just use this as illustration to show you how to compute an index. Now, when you look at this index from the data, you can see that this is a simple index, okay? It is not an aggregate index. It is not a weighted aggregate index. It is just a simple index. And I just want you to feel your hands a little wet in the computation of a simple index, okay? I might give you another assignment. Maybe next week, we will go through an assignment using a complex index. I'm going to find some problems where we're going to walk them through Excel so you can see how we can compute a weighted index that's a little bit more complex than this. All right, but I'll let you know what we're going to do. All right. Okay, next week is Thanksgiving. Am I correct?
Yes,
Yes,
Professor.
correct.
Okay, so there'll be no class next week. So I'll see you guys on December 5th.
Okay,
Okay.
Professor. Thank you.
All right. Okay.
Professor,
So, yes.
just had a few questions before you go.
Okay.
1 second. Yeah. Okay. So yeah, I just had a question on some of the assignments. So I got a little sidetracked on a few of the assignments
Okay.
past the due date. Can I still submit them?
Yes, you can still submit them. Send me an email, and I'm going to reopen all the assignments back to whenever you need to have them open. You can still submit them. Yes.
Okay. Yeah, I think they are like some of the links I still see they are active. So you might not have to reopen them, but
Okay.
if there is one there that it's needs to be closed, I can email you.
Sure. Sure. Absolutely.
Okay. And also, since it is late, would it what's the
I will not
percentage?
penalize you. I will not penalize
Okay. Okay.
you. All right.
Okay. Okay. Thank you very much, Professor.
All right. I appreciate your time.
Thank you.
Any other questions?
Professor, thank you.
All right. Enjoy your evenings and enjoy your Thanksgiving if I don't hear from you again.
Thank you. Enjoy. Happy Thanksgiving as well. Thank you.
All right then. Bye.
Bye-bye.